scientists are raising the alarm. A new threat is approaching, and this time, it's heading for the Moon. A massive asteroid, designated 2024 YR4, is on a collision course that could bring it dangerously close to the Moon in the coming months. Roughly the size of a Manhattan skyscraper, this space rock poses a potential threat we've never quite seen before. While it's impossible to predict exactly what would happen if it strikes, such an impact could unleash devastating effects on the lunar surface, with consequences for Earth that remain unknown. What makes this more alarming is the lack of comparable data. We're facing an unsettling uncertainty. Asteroid 2024 YR4 was first detected on December 27, 2024, by Chile's Asteroid Terrestrial Impact Last Alert System, ATLAS. Classified as an Apollo-type near-Earth object, it's part of a group of asteroids that cross Earth's orbit and could come uncomfortably close to our planet. On February 12, 2025, NASA issued a warning that shocked many in the scientific community. YR4 had reached level 3 on the Turin Scale, a rarity in asteroid tracking. This scale, ranging from 0 to 10, measures the potential danger an object poses. A level 3 rating suggests a credible risk of a regional scale impact. For perspective, only one other asteroid, Apophis 99942, ever reached a higher level, briefly hitting level 4 back in 2004. Although the initial scare was real, NASA soon revised its evaluation. The risk level dropped from 3 to 1.6, and eventually, the asteroid was removed from the scale altogether. That gave everyone a sigh of relief, until now. The latest concern isn't Earth, it's the Moon. Could 2024 YR4 collide with it? What would that mean for our planet, and where did this mysterious object even come from? Interestingly, the asteroid's name, 2024 YR4, sounds more like a droid from Star Wars than a cosmic threat. But there's logic behind the code. 2024 marks the year it was discovered. The Y refers to the second half of December, and R4 indicates it was the 117th asteroid discovered in that period. While these alphanumeric names help astronomers categorize and track objects, they can be confusing for the public. That's why more memorable nicknames are often used when asteroids make headlines, like the infamous ones named after gods of the underworld. For now, 2024 YR4 remains under close observation. Whether it strikes the Moon or simply passes by, it serves as a sobering reminder: space is full of surprises, and not all of them are friendly. Asteroid YR4 didn't earn a catchy nickname, perhaps because it already sounds like the name of a friendly robot. But make no mistake, this space rock is anything but harmless. Measuring between 53 and 67 meters in diameter, and moving at immense speed with substantial mass, YR4 is classified as a potential city killer. If it were to strike Earth, it could annihilate a major city like New York or Berlin, or cause a devastating tsunami if it landed in the ocean. Thankfully, experts breathed a sigh of relief when it was initially ruled out as a threat. Although global efforts are underway to build asteroid defense systems, and we theoretically have some tools for planetary protection, no one wants to see such a scenario play out for real. But now, a new headline has emerged. Recent data from the James Webb Space Telescope indicates a change in YR4's trajectory. There is now a 4.3% chance the asteroid could collide with the Moon on December 22, 2032. If YR4 were to hit the lunar surface, it wouldn't alter the Moon's orbit. The Moon is simply too massive, and the asteroid too small. But what's less clear is the potential impact on Earth. Our understanding of the dynamic relationship between Earth and its lunar companion is still limited. A significant impact on the Moon could possibly lead to months, or even years, of natural disasters, severe weather, and climate instability on Earth. So, what exactly would happen to the Moon? While it lacks an atmosphere, water, cities, or life as we know it, the Moon does have mountains, valleys, ancient craters, and vast expanses of dust. A major impact could dramatically reshape parts of its surface. Without atmospheric friction to hold anything back, the collision would launch dust and debris into space. It could also trigger moonquakes, seismic events unique to the lunar environment. This raises a crucial question: could that debris pose a threat to us? The answer is yes. Depending on its speed and direction, fragments of dust and rock could reach Earth, damage satellites, threaten spacecraft, or even affect missions like the James Webb Telescope. Even more unpredictably, if the Moon experiences a series of powerful quakes, its gravitational pull might temporarily shift, potentially affecting Earth in unknown ways. In short, if this event happens, it will be both historic and dangerous. Observing it safely from the Moon or through instruments is one thing, but experiencing the fallout on Earth is another. One thing's for sure: a lunar impact like this would not go unnoticed. That's why projects like ESA's NELI, Near-Earth Lunar Impacts, initiative are monitoring closely, tracking the Moon's surface for just such collisions. Imagine the Moon as a cutting-edge research lab for asteroid defense. With no atmosphere to shield it, even the tiniest space rocks strike its surface with full, unfiltered force. The European Space Agency, ESA, is leveraging these impacts to deepen our understanding of asteroids and meteoroids. Through the NEOMAP project, short for Near-Earth Object Lunar Impacts and Optical Transients, ESA has developed a system that captures these extraordinary collisions in real time. Each time a small object hits the Moon, a brief flash of light occurs. These silent bursts of energy, invisible to the naked eye, are detected by sensitive telescopes. Since the project began, scientists have recorded over 100 such impacts, most lasting just seconds, but shining brightly against the Moon's dark surface. One particularly striking event took place on March 1, 2020. Two observatories, the Sharjah Lunar Impact Observatory in the UAE and the Niliota Telescope in Greece, captured the same bright, sharp flash. The space rock behind it likely weighed only a few kilograms, but traveling at over 72 kilometers per second, it instantly turned into a fireball that reached temperatures of several thousand degrees Celsius. These dramatic collisions may seem distant, but they're incredibly valuable to scientists on Earth. By analyzing the light from these impacts, researchers can determine the size, speed, mass, and composition of the objects. This data is crucial. It goes straight into databases used to evaluate potential threats to our planet. The more we learn about the frequency and intensity of such strikes, the better prepared we are to identify, and maybe even prevent, future asteroid impacts. NASA is also actively involved. Through its Lunar Impact Monitoring Program, and in collaboration with ESA and other international space agencies, NASA helps form a global network. This network is turning the Moon into an early warning system for asteroid threats, one that could one day help save lives. Asteroids are elusive and dangerous. They're usually small, dark, and move at incredible speeds. Spotting them early requires highly specialized telescopes and sophisticated early warning systems. Not all telescopes are up to the task. Traditional observatories track distant, stationary objects. Asteroids, on the other hand, are fast-moving and faint. That's why wide-field, ultra-sensitive telescopes with automatic motion detection are used to spot them. One of the most important is Pan-STARRS, located in Hawaii. It scans vast portions of the night sky each evening, detecting even the smallest movements. In 2017, it discovered the strange interstellar visitor Oumuamua. Another system, Atlas, also based in Hawaii, was specifically designed to detect small objects like asteroids or comets before they enter Earth's atmosphere.